All right, we're going to do the Coase problem static version right now. Bill versus Madison. We have Beefman Bill, who owns 10 acres, but it's low productivity. It only produces 100 pounds of fodder per acre. And so we'll multiply the acres times the productivity to get the total fodder. He's got a neighbor, Madison, and she bought this lovely piece of land to have her little hobby farm, but she doesn't run any cattle, and she's not there. So Bill cut a hole in the fence so he could run his cows on Madison's land because, she's not there. And so that's the number. The number of cows that Bill has on his own land is 50, and he ran his cows out there. So the total weight of cows that Bill has is 50 times 500, and so the total growth, and we have a growth function here, which I pulled off the web, quite honestly, which is the total weight times is the fodder minus the total weight times 0.04, 4% of the body weight. If they ate more than that, then they grow at 1%, or 0.001%. And if they eat less than that, then they lose weight, and he loses money. So these are sort of real cows. They have to eat enough to grow. And so we're throwing weight on cows, or we're not. And we see with 50 cows on Bill's, they're not growing at all. And with 50 cows on Madison's, they're growing at gaining 2,500 pounds. And so total at that point is we have 2,500 pounds. And we put our baseline solution here. I just don't worry about that. I'm going to erase it for now because it's an error. So what we have going here right now is the total weight gained, and we'd like to maximize that. And we could go over here and do, like, we could do 30 cows. Does that make it higher? Yeah, it's 3,100. We could do 7. We could do 50. We could take some off of Madison's. What if we did 70 and 30? Oh, well, actually, we lose a lot there because Bill's cows are getting skinnier. Remember, these are real cows that get skinnier when you don't feed them, or they're on bad pasture. So I'm going to go back to the 50 and 50 at our start point, and we're going to run Solver, which you could have gotten by going to File, Options, Add-ins, CoaseAndSolver Go, and turning it on. Mac people, it's in Tools. And we'll say it's all turned on. We're going to say OK. You won't see most of these because these are extra things that I have that you don't. But you should see Solver. And so we have this. So we're going to go to Data. And you should see Solver up here. You might have to restart, Mac people. And so what we want to maximize is the total growth, which we have here, which is the sum of Bill and Madison's. And we want to change how many cows we put on Bill versus Madison. Acreage, and the constraint, which is here, we're going to click change. So you see how you would do that is we select that the total cows, which are the 50 plus 50, are less than 100 right now, and we say OK, and we're ready to go. And we're using the GRG nonlinear solver. We'll talk about differences in these when I'm in class. And so lo and behold, it tells us that Bill should move a whole bunch of cows to his land, to Madison's land, and that way he could make more money. And we can say OK. And remember, our original solution was 2,500, and so if we subtract the two of those, Society 625 better pounds of beef off by Bill cheating Madison, and Society could have paid her the difference, and they both would be better off. And this is the Coasean argument that sometimes if the factors of production, if Society could be better off, or maybe if Madison really, it wasn't worth $625 to Madison to allow the cattle on there, Bill could run 25 cows on his land, and Madison could pay him $50 or $625 not to have the 50 head of cattle on her land. And that's where Coase becomes reflexive is the optimum doesn't depend on who owns the land, depends on the factor productivities of those resources to optimize social outcomes. And if the property rights were all Bill's, we would end up here, and if the property rights are Madison's, and she gets to either charge Bill or pay him to not have her fences cut, the solution ends up the same. Of course, there might not be the social optimum in the sense we think people should value property rights and such.